Hi guys, I Aziz welcome you to CoedMaster. In this video, I will talk about shallow and deep copy in JavaScript. We will learn what it means by shallow copy and what the shortcomings of shallow copy are. Then we will learn how deep copy is going to help us solve the shortcomings of shallow copy. And in the last, we will learn how to implement deep copy function from scratch. So without wasting any time, let's get started. Alright guys, so let's start with a simple example. Over here I have created one object with the title JavaScript conference. Okay. Now if I ask you that in how many ways we can create a copy of this object, then perhaps you could come up with a very quick solution. So there are three methods which is a very quick way to create a copy of any object. Number one is the spread operator. Number 2 is the object.assign method, and number 3 is the object.create method. Great. So let's see how this method helps us in creating the copy of this object. So let's run this program and boom, we get the output. So you can see over here that we are getting the three values of this console log. Number 1 is this object, number 2 is this object, and number 3 is the title. So far, so great. So what do you think? Are we done with copying the object? I don't think so. So let me add one more property to this object. So let's add one more property over here with the name attendees. Okay. So we are going to do one more thing over here. That first we are going to print the calendar event. Then we will create a copy of this object. Then we are going to modify the original object with the help of calendar event variable. So we are going to call calendar event dot attendees dot push. And we are going to push one more attendee to this array. The name of that attendee is Bob. And then we are going to print all the three variables. Let's save the file and run the program. And boom, you can see the output. So this object is the output of this log, the first log, and this three output is the log of this log. Now, if you carefully observe this log, you will see that first we are getting attendees as John, and then we are getting attendees as John, Bob. And here, let's replace the title with attendees and run the program. And you will see that here also we are getting John and Bob. So if you observe this carefully, first we are cloning and then we are updating the original object. Still, the update is reflecting in the newly created object. Why is it so? What is the reason that even after updating the original object, it gets reflected in the newly created object? So the answer is pretty much quite simple. That all of these three methods are creating the shallow copy of the calendar event, not the deep copy. So what is happening over here? That attendees is an object which is of type array, and this array is stored somewhere in the memory, and both the objects, the original objects and the newly created objects, shared the same object from the memory. So what happens here is when we update the attendees array, the same reference is being used by the original object and the newly created object, which is why it gets reflected in the newly created object. So far so great. I hope you understood the concept of shallow copy now, that in shallow copy it's not going to create the entire new array from scratch, rather than it's going to use the exact same reference in original array as well as in the newly created object. Great. Now how we are going to solve this problem? So we can easily solve this problem with one more trick, which is a javascript.stringify method. So we can simply comment it out and we can copy the third line, uncomment it, and over here instead of all of these three methods we can simply use json.stringify to convert this object into string, give it a calendar event. Then once the object is converted to string, we are again going to parse this object to convert it into the object like this. This time we are only going to console shallow copy 3 and run the program. Now you can see that even after updating the attendees on the original object, it is not reflecting in the newly created object. The newly created object has still the John in the attendees. Excellent. So we somehow have solved the problem of a shared object. Okay. So this time we are getting the new array instead of shared array. Excellent. But what happens if we have a circular reference? So let's see one example. So let's remove all of this piece of code and let's write two objects. So as you can see over here is we have two objects, object 1, object 2. Object 1 has a reference to object 2 and object 2 has a reference to object 1, which means we have a circular dependency. So what happens when we have this type of scenario? Our JSON.stringify prints the clone object. Let's see it. So let's give object 1 to this JSON.stringify method and try to console shallow copy 1. Sorry, shallow copy 3. Okay, save the file and run the program. You will see that the program, the JavaScript engine is yelling at us and the error is converting circular structure to JSON is not allowed. As simple as that. So when we have circular references, JSON.stringify method is not capable of solving this circular reference, which is why we are seeing the error over here. Now, we have tried all the possible ways by which we can create the clone of an object, but in all the solutions we are kind of facing different kinds of problems. So what is the correct and sturdy and the strong way or the concrete way to solve this problem of cloning the object? So this is the exact scenario where the deep cloning concept comes into picture. So what deep clone exactly does? It's gonna take an object and it's going to create the new copy of all the key value pairs in the object. Even if this object has an array or nested object or nested map or nested set or nested det, it is going to create the new object for each of the type. Okay. Now let me take you to the browser. So here you will see that in JavaScript we have this method with the name structured clone, and the purpose of this method is to create the deep copy of the given object. And internally this structured clone method uses the structured clone algorithm. Okay, so let me show you the structured clone algorithm over here. So it's not like structured clone algorithm is going to clone everything. It also has some shortcomings. So here there are few things which cannot be cloned using the structured clone method, and these are functions, DOM nodes, index, last index property of regex, property descriptors like setters, getters like metadata, the prototype chain, and the class private properties. So all of these things cannot be cloned using the structured clone. Okay, now moving on, here we have some supported types. So all of these JavaScript types can be cloned using structured clone method. Okay, error types can be cloned and web APIs can also be cloned. So this is the default method which comes with the JavaScript. Now let's take the inspiration from this structured clone method and write our own implementation from scratch. Cool. So let me clear the console. Let's head over to example2.js, and over here I have created two objects. One is the address and one is person. And to create the circular reference, I have added one property on this address object and which is pointing to person. So we can say that person is pointing to address, address is pointing to person, and again person is pointing to address. Excellent. Over here I have written a deep copy function, and this function takes two arguments. One is the entity on which we want to create a copy. The second one is the visited map, and this visited map is used to handle the circular reference. We will talk about it in a bit. Okay. In the bottom I am calling the deep copy function by giving it a person object, and this function is going to return us a clone person object, and here I am logging some messages. Okay, we will see it in a bit. Now what are the cases we are going to handle in this function? So here we are going to handle the primitive types, objects, arrays, date, map, set, and the circular reference. Excellent. So as you can see, I have commented so many things over here just to make this algorithm pretty simple. So we are going to follow this template and we will implement each step one by one, okay, to complete this algorithm. So let's start with the first step. So first step is we are going to handle the primitives. So to handle the primitives, we have to write a condition. If entity is equal to null, or if the type of entity is not equal to object, which means if it is equal to null or it is not equal to object, then in this case we're gonna simply return the entity from this function like this. Excellent. Now next step is we are going to handle the circular reference. So how we are going to handle the circular reference? With the help of map. So whenever we see any new entity, we are going to store that entity in the visited map against the computed property of that entity. Okay. So here we can simply check if the visited dot has this entity. So if we have seen this entity before, then we can simply return the previously computed value like this, visited dot get, and we are going to give entity to this method. Great. Now next we are going to handle the date object. So if the entity is an instance of date, then we have to return new date object like this by passing it the entity dot get time method. So get time method gives us the date in milliseconds, and that milliseconds will be provided to a new date function, and it's going to return a new object. Excellent. The next thing is we are going to handle the map. So here we need to check if the entity is an instance of map or not. If it is, then first of all we are going to create the new map. So we can call it map copy is equal to new map, and as soon as we see this entity, we have to mark it visited dot set. The key is going to be entity and the value is going to be the map copy. Great. And in the last we can return this map copy. Excellent. Now in between we have to process all the elements of map. So for this we can use entity dot for each method. Okay, for each method takes one callback, and this callback is going to receive two arguments. One is the element itself and the next one is the index. Okay, so in case of map, the element is going to be the value and the index is going to be the key. Amazing. Then once we get the key and value, we need to store that key and value in the map copy map or a new map with the help of set method. Okay, but there is some nuances here, that the value and key on this entity might be of type object, so we cannot directly store the key and value inside the new map. So for this we have to again call the deepCopy method to recursively convert this value and key into the new object. Okay, so for this we have to pass key and the visited map. Great. Then again we have to call deepCopy. This time we will pass the value and the visited map. Excellent. So this way we will handle if the entity is map. Okay, next thing we will handle if the entity is of type set. Okay, so just copy and paste over here, and in place of map we just have to replace with set. So this time we are going to create a new set. We call it a set copy. Then we are going to mark as visited, and then we will go to all the elements of set. So set has only values, so we will get the value over here. Then we will use set copy dot add to add this value into this newly created set by calling the deepCopy again, and in the last we are simply going to return the set copy. Amazing. So map is done, set is done. Now this is the time to handle array. So in case of array, we have to check if the given entity is array or not. So for this we have to call array.isArray method. Okay, if it returns true, which means this is an array. So in case of array, we are again going to create a new array. So we can call it copy array with the new array, and we are going to mark it visited. So we can simply copy this visited statement over here to here. We give it a copy array, and in last we have to simply return this copy array like this. And here we will iterate over all the elements of array using the for loop. So let's write for loop. Let's initialize one variable I, which is equal to 0. I is less than entity dot length and I plus plus. We will go into the loop, and here we will use the copy array to go to a specific index, and then we are going to process the element of array. Again we have to call the deepCopy because the values of array could be of type object, and we have to recursively go to that value and create a fresh object out of it. Okay, then we have to pass entity of I and the visited map. Great. So we are done with the array as well. In the last, if all of these conditions are false, which means this is a plain object. So if it is a plain object, then we have to create a new object. So we have to create constant copy object, copy obj, which is equal to object dot create. So here we are using a create method to create a new object, and we also have to maintain the prototype chain. So to maintain the prototype chain, we have to call object dot get prototype of, and here we need to get the prototype of entity so that we can attach that prototype to the newly created object. Amazing. And then in the last we are going to simply return the copy object, and we forgot to mark it visited. So let us mark it visited like this. And now we are going to iterate over all the keys of the object using for in loop. So let item, or we can say that let key in entity. Okay, so we are going to iterate all the keys of entity, and here again we need to check one more condition, that if the entity dot has on property, and we are going to give it a key. So why we are checking has on property? The for in loop iterates over all the keys of the current object and its parent object. So it's gonna get all the keys from the prototype, but we do not want to iterate over prototype because we have already attached the prototype of this entity to the newly created object, which is why we are checking if the currently iterating key is owned by this entity or not. If it is, then we will go to copy object at the same location, and then again we have to recursively go to this value. And how we are going to get the value? By using the entity square bracket notation and give it a key. This way we will get the value, and we will go recursively to that value to create the fresh object out of it, because maybe the value is of type object. Okay, so this is our final implementation where we are handling the primitives, then we are handling the circular reference, then we are handling date, then we are handling map, set, array, and in the last we are handling the object. So with this implementation, let's save the file and run the program. So this time we have to update to example 2, run the program, and boom, you will see the output over here. So here there are basically 4 logs. So you can see the first log over here, and here we are checking if the cloned object is equal to original object or not, and for this we are getting the false, which means we are absolutely getting the new object because the reference of both the objects are different. Great, amazing. Then we are printing the person clone. So whatever clone object we got from deepCopy, we are printing over here. So this is our clone object. Next thing, we are checking if there is a circular reference or not. So we are checking like this: if the person clone dot billing address dot person is equal to person clone or not. And this time we are getting true, which means it is having the circular reference. Okay, because the billing address has person and we are getting the new clone of person, and these two keys are pointing to same reference. So which is why there is a circular reference. And it is obviously from here you can look at this object, it is clearly saying that we have a circular reference over here, we have a circular reference over here. Excellent. Now in the last we are printing the circular reference. So if we go to person clone.billingaddress.person, we are printing the person object. So which is a clear indication that there is a circular reference and we are smartly handling the circular reference in this algorithm. Amazing. So far so good. So in previous example, we saw that when we were creating the clone of an object, we were getting the exact same reference of a nested object in the original object and the newly created object. But here with the help of deepCopy, we are not getting the exact same reference. Rather, we are creating the new objects from scratch for each new sub-object. Okay. So I hope by now the concept of deepCopy is clear to you, that how we can write the deepCopy function from scratch, how it works, and what are the challenges we faced when we didn't have deepCopy function handy. So this is pretty much all about deepCopy function in JavaScript. Alright guys, this is all from my side for this video. If you learned something valuable from this video, then please hit the like button in order to make YouTube algorithm happy. Please subscribe to this channel and don't forget to click the bell icon so my friend you never miss any upcoming videos. Thanks for watching. See you in the next one.